Welcome, young dinguses, to our last video lesson for Chapter 3. Now, just giving you the big old warning here, being that it's the last section, we are going to put everything together that we have learned and add a little twist to it. So we're not going to be solving one step or two step or even those multi-steps. Instead, we're going to combine all those multi-step problems with also throwing variables on either side of the equation. So it's going to be a little challenging. So as we go through this, make sure if you need to pause the video, do so. Go back, rewind. If you have questions, make sure you jot them down. Otherwise, let's jump right into it and get started. All right, so when we have variables on both sides of the equation, here's what we're talking about. Let's say we give you an example like 2x plus 4, instead of equaling a number, is going to equal let's say 15 minus x. Okay, made up this problem, but notice how we have an x on one side and an x on the other side. So our goal in this video, when we try to solve for x, when we have x on both sides of the equation, our goal is to get the variable on one side of the equation. Doesn't matter if it's left or right side, we'll talk about that, but you're going to try and get the variable on one side of the equation. And then we're going to use all the tricks and trades that we've learned in previous sections and should be able to solve. All right, so if you take a look, here are our steps for solving these equations with variables on both sides. Step 1, use the distributive property if you see it. Right? Remember, what does distributive property look like? We're going to have a number with parentheses and maybe x minus 2 inside. When you see something like that, remember, we're going to distribute first. Then what we're going to do is simplify each expression on each side of the equation. So we're going to look on the left side, for example. Look on the right side. Can I simplify either side first? Meaning combine like terms. CLT. Sounds like a delicious sandwich without bacon, but then it wouldn't make it delicious. I don't get it. Anyways, combine like terms when possible. Next thing we're going to do is try, and this is the key part, and step 3 is where we're going to look. We're going to try and collect the variables on one side of the equation, whether it be the left side or the right side. My goal for this and for you guys is to look and try and find the easiest thing to do, okay? And the one thing I like to write, or that what I want you to write down, is try to avoid negatives. So when you get to this part, oopsies, negatives with an A, when you get to this part, you're going to use the properties of addition, subtraction, multiplication, division. Just like you would with numbers, you're going to bring the variable to one side, but you're going to try and do it so that you avoid any sort of negatives. Then we're going to do step 4, use properties, the same properties of equalities to get the variable by itself. This, once we get to step 4 and step 5, this is the stuff you know how to do already. This is the stuff we've been doing all chapter. And then the last thing, I know you guys don't like to do it, nor do you want to do it. You're just going to come up to me and say, is my answer right? Well, remember, I'm going to say to you, check your solution. So if you're not sure, if you have it, check the solution. All right, so let's take a look at some examples. First one we have 2x minus 4 equals 12x minus 14. So this is our first one. We have a variable 2x and 12x. But notice that the equal sign here is exactly smack dab in the middle of the problem. So can I combine those terms? And the answer is no, you can't combine them as is, because the equal sign serves as a barrier. In order for me to combine these, I need to take one of these, either 2x or 12x, and bring it to one side of the equation. In order to do that, we're going to use our properties of equalities. So I see 2x and 12x. Okay? I want to combine these, but I can't because that's equal sign. So what I'm going to do is I'm going to look at, for this one, I'm going to look at 2x. I see 2x is positive. If any time I want to bring something to the other side, I'm going to do an inverse operation. So 2x is positive. In order to bring it to the other side, I am going to subtract 2x from that side, and I'm going to subtract 2x from over here. Because remember, whatever you do to one side of the equation, you got to do to the other. What that's going to do is that's going to cancel out the 2x on this side. Negative, or 2x minus 2x is 0. That's going to leave me with negative 4 equals 12x minus 2x is 10x plus, oopsie daisies, not plus, that's going to be minus 14. All right, so what we did there is we brought the variables to one side of the equation. Now I am left with something that we have done before. 10x minus 14 equals negative 4. Remember, it doesn't matter that my x is on the right side of the equation. My goal is I'm going to try and isolate that variable. So we're going to do inverse operations. So I take a look first. I have a two-stepper here. I have 10 times x minus 14. So we're going to go opposite. We're going to start by taking care of the negative 14 by adding 14 to that side, and again adding it to the other side. Going to get that to cancel there. Negative 4 plus 14, that's going to give us 10 equals 10x. And the last thing, 10 times x, right here, we're right next to the variable that's times. We're then going to divide by 10 from that side, divide by 10, and that's going to give me 1 equals x. Same thing as saying x equals 1. Okay, so the first step was the most important part. We're going to collect like terms. Notice what I did here is just like we would if we were bringing just ordinary numbers. We're going to use an inverse operation to get the variables on either side. All right, I'm going to zoom in a little bit. Let's take a look at number 2. Number 2, we have 2 times x minus 4 equals negative 2x minus 10. First thing I should do here, I see the parentheses. First step, check to see if you need to distribute. So yes, I need to distribute the 2 to the x and the 4. I'm not going to distribute anything else because notice the equal sign forms a barrier. That's going to give me 2x minus 2 times 4 is 8 equals negative 2x minus 10. Okay, so what I have here is I have 2x minus 8 on the left side, negative 2x minus 10 on the right side. I'm going to try and collect. I see the 2x on the left, negative 2x on the right. I'm going to try and get them to the same side. I want you to think about this, though. I have positive 2x over here. In order to bring it to the other side, I'm going to subtract 2x, do the inverse. But I'm going to have negative 2 over here minus 2. That's going to give me a negative. What I like to do is try to avoid negatives. So instead, I see this negative 2x. In order to bring it to the other side, the inverse operation would be to add. So I'm going to add 2x because what that's going to leave me as a result is a positive on the opposite side. That side it cancels, which is Gucci. But this side you're going to get 4x minus 8 equals negative 10. Now the number attached to my variable is not negative, and I don't necessarily have to worry about the negatives too much. All right, next thing, this is where it gets easy. I have 4 times x minus 8 equals negative 10. I'm going to start with the negative 8, and I'm going to add that to both sides. Gets that to cancel here. Leaves me with 4x equals negative 10 plus 8 would be negative 2. Then last thing, I have 4 times x. So, okay, divide by 4. Divide by 4, you're going to get x equals, well, be careful here. A lot of you are going to want to say negative 2 divided by 4 is negative 2. But remember, negative 2 is smaller. It's kind of funny how I know the mistakes you're going to make at times. So what we're going to do is treat this as a fraction and simplify. Negative 2 over 4, you can simplify by taking a 2 away. You're going to get x equals negative 1/2. So I get 1/2 as my answer. Okay, so this one distributing first. Let's take a look at number 3 now. Oh boy, oh my, whoa, what's going on here? All right, I got 80n minus 30n equals negative 10, parentheses 2 minus 5n, minus, parentheses, n minus 1. First thing you're going to do here is look to distribute. So can you distribute? Yes. On the right side, I can distribute negative 10 there and there. And be careful here, we talked about this when I see negative parentheses. Wait a second, that means there's a 1 in front. So what am I distributing? Negative 1 to each of these terms. All right, so let's start by rewriting our equation then. So I have 80n minus 30n equals, then I'm going to have negative 10 times 2, so that's going to give me negative 20. Now be careful here, remember that this is not just 10 times 2, it's negative 10. Right, so the next one I'm going to have negative 10 times negative 5n. That's going to give me positive 50n. Same thing here with the negative 1. This is negative 1 times n minus 1. So when I get that, I'm going to have minus 1n. And then negative 1 times negative 1 is going to give me positive 1. All right, so I distributed. Next thing what I'm going to do is on either side of the equation, I'm going to look to see if I can simplify. Can I simplify the left side? Can I simplify the right side before I do anything of crossing over the equal sign? On the left side, I see 80n minus 30n. Of course I can simplify. That is 50n. And that's going to equal. On this side, okay, let's look to see if we have like terms. Well, I have 50n and negative 1n. So 50 plus negative 1, that's going to give me 49. Oh, that's a 5. Never mind. Holy cow. That's going to give me 49n. Same thing with this one. I got negative 20 and then positive 1. So combining like terms there, negative 20 plus 1 is going to give me negative 19. Alrighty then, let's see what we can do next. So I see that I have 50n on this side, 49n on this side. So I got my n's on opposite sides of the equation. I want to get them on the same side. Okay? Notice how I have just 50n over here. There's nothing else. So when you see that you have a variable isolated, we're going to take the one that's not isolated and we're going to bring it across to this one. Because we don't have to remove anything else then other than maybe the number in front. So I'm going to take 49. Notice how 49 is positive. Okay? So what I'm going to do is I'm going to subtract 49n from this side. That's going to cancel, but I have to make sure to subtract it from this side as well. 50 minus 49 is going to be 1n. That's going to equal negative 19's left over there. Remember 1n, I don't really have to worry about that 1, so I can just write this as n equals negative 19, and holy smokes, there's our answer. Okay, so negative 19 is our solution. All right, one last example here going through this. I have 4 parentheses n plus, oh my god, 1/2, freak out, there's a fraction. That's going to equal 5 times 2n minus 2. First step, can I go ahead and distribute? You betcha. On this, I'm going to have to distribute the 4 to the n and the 1/2. This, the 5 to the 2 and the negative 2. Okay, equal sign right down the middle. So, 4 times n right here is going to be 4n. Plus, oh my god, I got 4 times 1/2. Oh, now I can write this out, but once we start getting used to fractions, I'm just going to have you guys think of something here. 4 times 1/2 is the same thing as saying like 1/2 of 4. So I want you to think, what is 1/2 of 4? God, I wish I could cue up some Jeopardy music there, but instead I just took a sip of my old coffee. But half of 4 is 2, is it not? Okay, so you can go ahead and show the work of multiplying fractions together, but I'm going to do that quicker. That's going to give you 2. Right side I have 5 times 2n, that's going to give me 10n. 5 times negative 2 is going to give me negative 10. Got variables on both sides. Check to see, can I simplify? Nope, those are not like terms. Can I simplify? Nope. So now I got to start bringing things together. I have 4n on the left, 10n on the right. I want to make these on, or get these on the right, on the same side. I'm sorry, can't talk. So which one should I bring over? Hopefully you said subtract the 4n from this side and bring it across over here, because that's going to give you a positive result. That's going to give me 6n minus 10, ooh, that rhymed, equals positive 2. Okay, now I have n on one side of the equation, so now it's just using inverse operations. So first thing I'm going to do is add 10. I'm going to start at the bottom of our order of operations here. I'm going to add 10 to this side. That's going to give me 12 equals 6n. Last thing, 6n means 6 times n, so I'm going to divide by 6. Divide by 6. That's going to give me n equals 2. And there's my answer. Again, I could check all these solutions, but I'm going to be lazy like you guys right now and not check my solution. Plus, I know these answers are correct because you can tell everybody that I'm the man, I'm the man, I'm the man. Okay? All right, as you go through and solve some of these problems, even some of the easier ones we did before or some of the more difficult ones we did today, there is one weird thing that can happen. And I'll show you these 2 examples. As you go through sometimes, one of your variables may cancel out or drop out of the equation. I'll show you what I mean by that. Okay? When something like that happens, when a variable cancels on both sides and it disappears, what happens is you get one of 2 things. The result that you're going to get is either going to be equal or it's not going to be equal. So when the variable cancels out, the variable disappears, that means one of 2 things. Either there is no solution to the equation, or what it means is that it's an identity and that any number, when plugged in, works. Any number can solve that equation. Let me show you what I mean. Okay, if I throw the problem here with the identity, I'm going to go through this a little quick, but I'm going to distribute the 2, distribute the 4. So that's going to give me 4x minus 8 plus 16. Notice I'm not distributing the 16 because there's a plus in between. So plus 16 equals 4x plus 8 And notice here what I want you to see is notice how I have 4x and 4x. But first thing I'm going to do is simplify this side. So negative 8 plus 16, that's going to give me 4x. These two would combine to give me plus 8. And that's going to equal 4x plus 8. Okay? You can see one thing if you notice right now. What I have on the left side is exactly the same as what I have on the right side. So this equals that. Well, that's kind of what an equation means, but let's talk more about that. If I were to then get rid of the x and say I want to bring my x's to one side like you have been doing all video, that's going to give me 8 equals, well, 4x minus 4x cancels, and what does that give me? 0x, which we don't write. So what you get is 8 equals 8. Well, 8 equals 8, what you would write down here is this is an identity. What does an identity mean? It means that my end result for this equation is true. 8 does equal 8. What this really means is that if I were to plug in any number into this equation, could be 2, could be negative 2, could be 1,563, doesn't matter. Anytime I plug a number in for x, it's always going to work out. Okay, the equation's always going to be true. There's not one solution, but there's infinitely many solutions. Okay? As opposed to this other problem on the right, I have negative 15y plus 7y plus 1 equals 3 minus 8y. When I combine the y's here, negative 15 plus 7, again, equal sign right here, so I can't combine that, negative 8. Negative 15 plus 7 is going to give me negative 8y plus 1 is going to equal 3 minus 8y. Okay, I have y's on either side of the equation, so what I'm going to do here is add 8y from this side to bring it over to here. Add 8y. Negative 8 plus 8 is 0. Negative 8 plus 8 is 0. Wait a second. What am I left with? 1 equals 3. So think about this here. The 8 cancels, or the y cancels out. The variable disappears because the number in front is 0. And you're left with 1 equals 3. Well, 1 equals 3, this does not make any sense. 1 does not equal 3. So this is a telltale sign that right now, since the variable cancels out and what I'm left with is not true, that this is no solution. This equation will never have a solution. And we'll talk later second semester about what this really means, but these don't have a solution to it. Okay? So in a problem, if you see that the variable cancels out, you have to look at the end result. If the end result is true, it's called an identity. If the end result is not true, it's no solution. So one little last nugget. All right, we got 2 last examples here. I want you to pause the video and give these a shot. Okay, I want you to try these, so pause. Pause now. If you haven't paused yet, please pause. Okay, go. Alrighty, check your work here. So on the left side, I had to distribute twice on the left and on the right. Then I got 10 plus 40m equals 12 plus 40m. I brought the m's together by subtracting 40 from here, brought over here. I was left with 10 equals 12. Well, 10 doesn't equal 12, you dingus. So again, not true. That means no solution. Same thing on this side, distributed. Distributed, had to be careful here. If you didn't do this side right, you don't get the right answer. Negative 2 times 6 is negative 12, and negative 2 times negative 2 is positive 4. So when I subtract 4x from your side, notice the x cancels out on both sides of the equation. Holy strawberries, Batman. And I'm left with negative 12 equals 12. And that represents an identity, which again means there are infinite number of solutions. All right, so remember, if the variables cancel, it could be no solution or identity. You got to be able to identify both of those. Again, this is the toughest section, kids, so make sure you put some effort into the practice. Ask plenty of questions because this is where we're going to have to spend some time, and this is where things are getting a little SASSY or sassy. Okay, hope you enjoyed, kids. We'll see you in class. Good luck on the practice. Peace. I'm out of here.
I'm sorry, Cody.
For what?
For letting you down. For being a loser.
Yeah, you are no loser.
That's the code, man, dude.
Target practice for all. Well, you came here today, you made that tough dude over there go the distance with it. You came here to get respect, and you got it. I guarantee you nobody's gonna be jerking your jockeys again.
Thanks, Cody.
Come here.
Oh, isn't that sweet? Giving your student a big hug. What are you gonna do later? Burp him?
Hey, come on, Mark, man. You ain't gotta listen to this jive. Get it home.
Bye, girls.
Best thing to do in a situation like this, just ignore her. Yeah.
Oh, yeah?
Ignore this! Second best thing to do in a situation like this, you kick the dude's butt real good, okay? All right. It's you and me, Cowpie. Hey, Ref. Think there's gonna be a little brief exhibition match between myself and this coach.
Bring it out, pal.
Right on.
Gentlemen,
Oh, so that's how it's gonna be, huh? All right.
Lucky point. Try it again.
Ah, don't mind if I do.
That's not fair. I was just getting warmed up.
Well, that's cool, man. I mean, we could do best out of 4, or 6, or even 10, man. I like throwing you around.
Yeah, me too. Want a piece of me, cow pie?
Okay.
You're on my
That's the code, man. Theater.